Hello, this is Mr. Stansbury. I'm going to take you through the 5K notes on parallel box plots. At the end of this, you should be able to create a side-by-side box plot with outliers, if any, with the given data. Okay, so we're just going to take a look at one example here, and example 24 from page 158. Pete, who wears the Perry the Platypus costume at Disneyland, has the choice of shopping bike or his 20-foot powered eco-friendly car to take to work. He has recorded his commute times with each vehicle, and they are as followed. Here's all the shopping bike commute times in minutes, and here's all the foot-powered car times in minutes. Pete wants to know which vehicle is quickest and also which is most reliable. Prepare parallel box plots to arrive at your answer. Okay, so this is really similar to what we did in the previous section, but we're also going to go through on how to do this same bit of information with outliers as well. Okay, so we are going to pull up our graphing calculator, and we're going to go back into Stat, and we're going to edit, because we're going to enter in all this data from both of these pieces here. So we're going to edit. And then in list 1, I've just put in my first set, the shopping cart bike. And then in list 2, I put in all my times for the foot-powered car. Notice all the feet down there. So, again, I've already gone through ahead of time and done that. So, if you'll remember from before, the first thing we're going to want to do is to sort our data. So we want to sort our data, and let's sort. We'll do second, and let's do list 1, and then let's do the same thing with list 2, and then there's our second, there's our list 2. Okay, so now all the data we have in here is sorted numerically, okay, from smallest to greatest. So now what we want to do is we want to make our stat plot. So we do second and then stat plot, or the y equals button, and we want to turn both of these plots on. So this plot here needs to be turned on, and then here's where the slight difference comes in. Instead of this one here, which shows our box plot, we're actually going to go over to this one here, which has the box and whisker plot with the outliers. You can tell because it's got the two little dots. Okay, so this is the first one. We want to use list 1. And for the mark on that, I actually, just to be consistent with what the book has us doing, I'm going to put a little plus. That's the closest thing to an asterisk that they have. Okay, and then I'm going to also want to do the same thing for our other stat plot. So, sorry, we go back into stat plot, and we got to turn the second one on. It is already on, and then again, notice over here it is already highlighted on the box and whiskers with the possible outliers. Now it's really important to make sure that you get list 2 on this one here. So second, and then hit list 2, and then again frequency we don't need to worry about, and then I'm going to change this over here to the plus. Okay. Now you're going to want to make sure that your window is going to fit all this data. So, let's see, the smallest piece of data in all of this looks like it's about, let's see, what is it, 13 in both of them. So I'm just going to start with 0 because that makes it look a little nicer, I guess. And then the biggest piece, let's see, we've got 43 over here, so I need to change that 35 to at least get our 43 in there. Maybe I'll just do 50. And then I'm going to leave my scale at 5. I could change it to 10, doesn't really matter, but now we'll have that. And again, the y minimum should be 0, y max should be pretty much anything besides, anything greater than 0 should be fine. And the rest is good to go. So we hit graph, and here is our box plot for the first one, which is the shopping bike. So here's the shopping bike. And then here is the foot-powered car data. So notice that the foot-powered car has 2 pieces of data that are outliers, whereas the shopping bike doesn't have any outliers, which is a little Curious because, again, it's got this 43, which is so far away from the 33, but the reason why it's not is because if you'll look, there's the variance on all these numbers is pretty great, because you got 13s, 14s, 18s, and then it goes up to 33s, 27s, 28s, and 43s. So the data is so widely spread that it makes your interquartile range bigger, which allows for a longer range here, so that this 43 actually fits in to that. Okay, so that one does not end up being an outlier. So this information here, let's take a quick little clip of it. Okay. And we can copy it in there. So here's our info here, so we can use that to arrive at our data. Pete wants to know which vehicle is quickest and which is most reliable. So quickest one looks like, again, these look like these have lower speeds, so the quickest looks like it is the foot-powered car. Is the foot-powered car. All right. And again, we can't say that it's quickest every time, but the quickest usually is the foot-powered car. All right. Which is most reliable? I don't know. I mean, I'd go with the foot-powered car here, because again, the data here is still not nearly as spread out as that. Okay, so this is still more reliable. So I would also go with the most reliable. Is also the foot-powered car. Okay, and again, you can see how it's fairly handy to have these two box and whisker plots side by side, so you can compare them. That's a great way to look at data. Again, the data's squished together nice and tight in here, and also it's significantly lower, especially with these up here, so that's why a foot-powered car looks like the best bet for Pete. Or you could just get like a real car, or maybe even a real bike, I don't know. So anyway, that's all there is for this section. If you have any questions, feel free to ask. Thanks.